To determine the appropriate subpanel size, first calculate the total load. Start with the air compressor, which draws 7.5 amps at 240 volts, resulting in 1800 watts. The welder draws 20 amps at 110 volts, which equals 2200 watts. The air conditioner requires 15 amps at 230 volts, totaling 3450 watts. The misting pump draws 15 amps at 110 volts, equaling 1650 watts. The first spare outlet is rated at 20 amps at 120 volts, providing 2400 watts. The second spare outlet, also rated at 20 amps at 120 volts, provides another 2400 watts. Adding all these loads together results in a total load of 12,900 watts. This 12,900 watts total load translates to 12.9 kilowatts. When sizing a subpanel, it's essential to consider future expansion. The calculated total load of 12.9 kilowatts requires a minimum subpanel rating of 14 kilowatts. To accommodate potential future needs, a slightly larger subpanel is recommended. Therefore, a 15 kilowatt or 125 amp subpanel would be a suitable choice. The feeder supplying the subpanel must be adequately sized to handle the full load of the subpanel. According to the National Electrical Code, specifically NEC Table 310.16, a 100 amp breaker with 1/0 aluminum or AL SER cable meets the requirements for a 125 amp subpanel. Based on the load calculations and NEC requirements, a 125 amp subpanel fed by a 100 amp breaker with 1/0 AL SER cable offers a cost-effective solution for this garage application. As an alternative, if it's certain that only the air conditioner and misting pump will operate simultaneously, a smaller 70 amp subpanel fed by a 70 amp breaker with number 2 AL SER cable could suffice. Remember, it's always advisable to consult with a licensed electrician for accurate load calculations and subpanel sizing to ensure safety and code compliance. The primary consideration in sizing a subpanel is to determine the total load it will serve. This involves calculating the wattage of all devices and appliances that will be connected to the subpanel. Once the total load is known, you can select a subpanel with an appropriate amperage rating. The NEC provides guidelines for sizing subpanels and feeders based on the calculated load. The subpanel amperage rating should be equal to or greater than the calculated load. This ensures that the subpanel can handle the anticipated demand without overloading. The feeder conductors, which supply power to the subpanel, must also be sized to carry the calculated load. NEC Table 310.16 provides ampacity ratings for conductors based on their size and insulation type. When selecting feeder conductors, it's important to consider the ambient temperature and any dirting factors that may apply. Dirting factors are used to reduce the ampacity of conductors when they are installed in certain conditions, such as in conduit or in close proximity to other conductors. Aluminum SER cable is a common choice for feeding subpanels due to its cost-effectiveness and ease of installation. However, aluminum conductors have a lower ampacity than copper conductors, so it's important to select the appropriate size to meet the load requirements. The NEC provides specific requirements for the installation of aluminum conductors, including the use of properly rated connectors and antioxidant compound. In addition to the load calculation and conductor sizing, it's also important to consider the overcurrent protection for the subpanel. The overcurrent protection device, typically a circuit breaker, is designed to protect the conductors and equipment from overloads and short circuits. The size of the circuit breaker should be matched to the ampacity of the feeder conductors. It's also important to select a circuit breaker with an appropriate interrupting rating, which is the maximum fault current that the breaker can safely interrupt. The interrupting rating should be greater than the available fault current at the subpanel location. When installing a subpanel, it's important to follow all applicable electrical codes and regulations. This includes properly grounding the subpanel and bonding all metal enclosures. Grounding provides a path for fault current to flow back to the source, helping to prevent electrical shock. Bonding ensures that all metal parts are at the same potential, reducing the risk of electrical shock. It's also important to label the subpanel clearly, indicating the circuits that it serves. This makes it easier to identify and troubleshoot circuits in the future. If you're not comfortable working with electricity, it's best to hire a licensed electrician to install the subpanel. A qualified electrician can ensure that the installation is done safely and in accordance with all applicable codes. Remember to always energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is energized before touching any wires or terminals. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, when working with electricity. By following these guidelines, you can safely and effectively size and install a subpanel for your garage or other application. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. The choice between a 100 amp and a 70 amp subpanel depends heavily on the anticipated load and the potential for future expansion. While the calculated load might suggest that a 70 amp subpanel could suffice, it's often prudent to opt for a larger capacity, such as 100 amps, to accommodate future needs. This is especially true in a garage setting where power tool usage or the addition of new equipment is common. A 100 amp subpanel provides more headroom and reduces the risk of overloading the system. The cost difference between a 70 amp and a 100 amp subpanel is usually not significant, making the larger capacity a worthwhile investment. The selection of the appropriate feeder cable is also crucial. Aluminum SER cable is a common choice for residential subpanel feeds due to its cost-effectiveness and ease of installation. However, it's essential to ensure that the cable is properly sized to handle the anticipated load. The NEC provides guidelines for conductor ampacity based on the conductor material, insulation type, and installation conditions. For a 100 amp subpanel, 1/0 aluminum SER cable is typically recommended, while number 2 aluminum SER cable is suitable for a 70 amp subpanel. It's important to consult the NEC and local codes to determine the specific requirements for your installation. The use of appropriately sized overcurrent protection devices, such as circuit breakers, is also critical for safety. The circuit breaker protects the feeder cable and the subpanel from overloads and short circuits. The breaker should be sized to match the ampacity of the feeder cable. For example, a 100 amp subpanel fed with 1/0 aluminum SER cable should be protected by a 100 amp circuit breaker. In addition to the feeder cable and overcurrent protection, it's important to consider the grounding and bonding of the subpanel. Proper grounding and bonding are essential for preventing electrical shock and ensuring the safe operation of the electrical system. The subpanel should be grounded to the main electrical panel using a grounding conductor of appropriate size. All metal parts of the subpanel should be bonded together to create a low impedance path for fault current. When installing a subpanel, it's always best to consult with a licensed electrician to ensure that the installation is done safely and in accordance with all applicable codes. A qualified electrician can perform a load calculation, select the appropriate equipment, and install the subpanel in a safe and professional manner. Remember, electrical work can be dangerous, so it's important to take all necessary precautions and follow all applicable codes. The National Electrical Code, or NEC, plays a significant role in determining the safe and proper installation of electrical systems, including subpanels. The NEC provides comprehensive guidelines for conductor sizing, overcurrent protection, grounding, and bonding. Compliance with the NEC is essential for ensuring the safety of the electrical system and preventing electrical hazards. The NEC is updated every 3 years, so it's important to stay current with the latest edition. Local electrical codes may also impose additional requirements beyond those specified in the NEC. It's important to consult with local authorities to determine the specific requirements for your area. When planning a subpanel installation, it's helpful to create a detailed wiring diagram. The wiring diagram should show the location of the subpanel, the feeder cable, the circuit breakers, and all of the connected circuits. The wiring diagram can be used to plan the installation, identify potential problems, and ensure that the system is wired correctly. It's also helpful to label all of the circuits in the subpanel. This makes it easier to identify and troubleshoot circuits in the future. The label should be clear and concise, indicating the purpose of each circuit. For example, a circuit that serves a garage door opener could be labeled garage door opener. When working with electricity, it's important to take all necessary safety precautions. Always de-energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, when working with electricity. Avoid working in wet or damp conditions. If you're not comfortable working with electricity, it's best to hire a licensed electrician to do the work. A qualified electrician has the training, experience, and tools necessary to perform electrical work safely and effectively. The cost of hiring an electrician may be higher than doing the work yourself, but it's worth it to ensure the safety of your home and family. When selecting a subpanel, it's important to choose a reputable brand that meets all applicable safety standards. Look for a subpanel that is UL listed or has been tested by another recognized testing laboratory. The subpanel should also be properly labeled with all of the required information, such as the voltage rating, amperage rating, and short circuit current rating. The subpanel enclosure should be made of a durable material that can withstand the environmental conditions in which it will be installed. The enclosure should also be properly sealed to prevent the entry of moisture and dust. When installing a subpanel, it's important to follow the manufacturer's instructions carefully. The instructions will provide detailed information on how to install the subpanel safely and correctly. If you have any questions about the installation process, contact the manufacturer or a qualified electrician. The NEC provides specific requirements for the spacing of conductors in electrical panels. These requirements are designed to prevent short circuits and ensure that the panel operates safely. When wiring a subpanel, it's important to maintain the proper spacing between conductors. Use cable ties or other means to keep the conductors organized and prevent them from touching each other. Avoid overfilling the panel with conductors, as this can make it difficult to maintain the proper spacing. The NEC also provides requirements for the identification of conductors. All conductors must be clearly identified with their purpose and voltage. This makes it easier to troubleshoot circuits and prevent accidental contact with live wires. Use color tape or wire markers to identify the conductors. The NEC specifies the colors that should be used for different types of conductors. For example, the neutral conductor should be white or gray, and the grounding conductor should be green or bare. When terminating conductors in a subpanel, it's important to use the proper tools and techniques. Use a torque wrench to tighten the terminal screws to the specified torque. This ensures that the connection is tight and prevents overheating. Avoid over-tightening the terminal screws, as this can damage the terminals. Use a wire stripper to remove the insulation from the conductors. Be careful not to nick or damage the conductors. Use a crimping tool to attach terminals to the conductors. The crimping tool should be properly sized for the terminals being used. When connecting conductors to circuit breakers, make sure that the breakers are turned off. This prevents accidental contact with live wires. Use a screwdriver to tighten the terminal screws on the breakers. Avoid over-tightening the terminal screws, as this can damage the breakers. The NEC provides requirements for the location of subpanels. Subpanels should be located in a readily accessible location. They should not be located in bathrooms, closets, or other areas where they are likely to be exposed to moisture or damage. Subpanels should also be located in a well-lit area so that they can be easily inspected and maintained. The NEC requires that all electrical equipment be properly maintained. Subpanels should be inspected regularly for signs of damage or wear. Loose connections, corroded terminals, and cracked insulation should be repaired immediately. Circuit breakers should be tested periodically to ensure that they are functioning properly. If a circuit breaker trips frequently, it should be replaced. The NEC provides guidelines for the safe disposal of electrical equipment. Old circuit breakers and other electrical equipment should be disposed of properly. They should not be thrown in the trash or incinerated. Contact your local recycling center or qualified electrician for information on how to dispose of electrical equipment safely. In addition to the technical aspects of subpanel installation, it's also important to consider the aesthetic aspects. The subpanel should be installed in a neat and professional manner. The wiring should be organized and the panel should be properly labeled. The subpanel should also be located in a place where it is not an eyesore. If you are not sure how to install a subpanel properly, it is best to hire a qualified electrician. A qualified electrician has the training, experience, and tools necessary to install a subpanel safely and effectively.